Java is the most popular programming language in the world. Today we're going to talk about its origin story, its characteristics, and what it's used for. Welcome to Kopek Explains Software, the podcast where we make computing intelligible.
This week we're going to talk about Java, a really important programming language. Can we just start with what is Java?
Java is both a programming language and a platform. The programming language gets compiled into platform-independent bytecode that then runs on the Java virtual machine. The Java virtual machine runs the actual Java program after it's compiled into bytecode. So this is different from a lot of other programming languages that are directly compiled into machine code.
And why was Java created?
Java was originally created in the early 1990s at Sun Microsystems. They were originally thinking about building a system for set-top boxes or for other kinds of appliances. It was led by James Gosling, who was an old-school hacker. He had been involved in the Unix world quite a bit and already had quite a reputation before he worked on Java. It came out in 1995 actually targeting the web and also the concept of write once, run anywhere on computing systems.
And what does that mean, write once, run anywhere?
The idea is you write the program in Java, it gets compiled into this platform-independent bytecode, and then it can run on any computing system that has a Java virtual machine. So the same program can run on Windows or Mac or Linux as long as those operating systems have a Java virtual machine. You obviously don't need to write the Java virtual machine. Sun Microsystems or later Oracle or an alternative implementation has already done that for you. So you as the programmer are freed of platform dependency. You just write your program in Java, you compile it to platform-independent bytecode, and then it can run on any machine. This is, of course, a big challenge to the operating system vendors. So Microsoft saw this as a threat to Windows in the 1990s. Because why would you need Windows if you could just get any computer and all your programs would run on it because they were all written in Java and then compiled to platform-independent bytecode? Then you wouldn't even need Windows. So Windows stops being this important layer between you and your computer. So Java was originally envisioned as this grand unifying piece of software, this unifying platform that would allow this write once, run anywhere. That wasn't exactly how things worked out. I also want to mention that when they were building Java, they were trying to build a language that was better than the languages that came before it, specifically C++. So they were very intimately familiar with C++. They wanted to improve on some of the things in C++ that led to programmers shooting themselves in the foot. So Java had things like automatic memory management. That's an old concept, but it's something that C++ didn't have. It had a simpler syntax. It was fully object-oriented, so everything is in a class in Java. Everything is an object. It was a safer language. It had better support for threading and concurrency. And so it was meant to be an improvement on C++, but then, of course, the big selling point was this idea of write once, run anywhere. And one part of the write once, run anywhere strategy was also having what are called Java applets, which was a plugin for web browsers that allowed Java programs to run within a web page. This was before JavaScript really took off, and applets were around for a long time, but they never really became a dominant paradigm. You can think about them kind of like what Flash later became to the web. They were a plugin that you'd have a little rectangle in your web page that had its own self-running Java program, and it didn't really interact with the rest of the web page. JavaScript, on the other hand, which we'll get to a little later, was a fully immersive client-side programming language for the web.
Who controls Java now?
Well, Java was originally created by Sun Microsystems in the early 1990s. Sun got purchased by Oracle in 2009, and so Oracle is now the steward of Java. However, Sun actually open sourced Java in 2007, and there had always been alternative implementations of Java. For example, IBM had an alternative implementation of Java. At one point, Microsoft had an alternative implementation of Java, but because they had changed how Java works in a couple of ways, they actually got sued by Sun Microsystems in the 1990s, and that's what led Microsoft to create C#. C# is a different language which runs on a different virtual machine, but it has a lot of similarities with Java, and you can see that origin story if you've programmed in both Java and C# about how they're similar because of this conflict between Microsoft and Sun Microsystems. So today, Java is an open source project, but it's mainly led by Oracle, who also makes a proprietary implementation of Java. Although there continue to be alternative implementations of Java, we would say definitely that Oracle leads the Java ecosystem.
And how is Java used?
Well, so it was originally created for web applications, as I mentioned, and this idea of write once, run anywhere on the desktop. But that's actually not where it found its niche. There were some real issues with early implementations of Java. Mainly, they were interpreted and very slow. Over time, the performance of Java has improved quite a bit, as it's moved from being an interpreted language to a just-in-time compiled language, and even today a lot of implementations are ahead of time compiled. However, that slowness really led to it not taking off as a form of writing desktop applications, or even applets never really reached the success that a lot of people thought they would reach. So Java had these issues about performance, and it never really made it in that space, but then it found its way into some areas that probably the creators never thought it would be so successful in. Especially since it had those performance issues, it's surprising that it made its way into embedded applications. In fact, a lot of computing devices that were created in the late 1990s, early 00s, that include a microprocessor ran Java, including things like DVD players, Blu-ray players, including a lot of early cell phones. The Java 2 Micro Edition was one of the main ways that people programmed early cell phones before smartphones. And so Java was like the programming language of cell phones, and then it actually became the programming language of Android too, and that's one of the major deployments of Java today. Now, an important thing to note is that Google's implementation of Java in Android is different from Oracle's implementation of Java. And those differences have actually led to a lawsuit that we covered on a previous episode that I will link to in the show notes. So Java is the dominant programming language of Android development, and a lot of Android is actually built in Java. However, it is a slightly different version of Java with a different virtual machine than the mainline implementation of Java from the open source project or from Oracle. Java is also used quite a bit in enterprise web applications. So a lot of large corporations build their back-end systems in Java. A lot of websites that you'll browse on when you're on Amazon or you go on eBay, a lot of that infrastructure in the back end is built in Java. So Java is actually the dominant language in enterprise applications and also in Android and also in a lot of embedded applications. But it never made it that big on the desktop. That doesn't mean there's not desktop applications, things like MATLAB or Eclipse or NetBeans or LimeWire that are built in Java. There certainly are. It's just definitely not the dominant language in that area in the same way that it is for enterprise web applications and for Android and embedded applications. Certain kinds of embedded applications. A lot of embedded applications are still in C or C++, but certain kinds of embedded applications.
But isn't JavaScript what's used on the web all the time?
Yeah, this is an important point. JavaScript and Java are two different languages. JavaScript was created around the same time as Java in 1995, 1996 when it first came out. And JavaScript has the name Java in it, but it's not actually Java. It has some really vague syntactic similarity to it, but they're two totally separate languages. And the only reason that they have the same name embedded in them is a marketing decision. Netscape and Sun Microsystems had something of an alliance, you'd say almost in 95, 96, certainly a close relationship. And there was a lot of hype around Java. And so when they came out with this lighter weight language for client-side scripting on the web, they wanted to get in on some of that hype. So the marketing department was like, why don't you put the word Java in the name? And so JavaScript is a totally separate language, and this confuses a lot of people. But Java is the heavyweight language used for all these different kinds of applications. JavaScript is the lightweight language that was originally for web scripting, but has now found its way into many other areas, and we'll probably do a future episode on JavaScript. But they're two totally separate languages, only connected by a marketing department.
So where's Java today?
So Java continues to be one of the most popular programming languages in the world. By many measures, it is the most popular programming language in the world. And it goes through an evolution process that's largely led by Oracle, but takes input from the community. It has the open source project. It has alternative implementations. It is a very, very popular, very important programming language. It's also one of the main programming languages in education. A lot of college courses are taught in Java. So a lot of Java programmers are being churned out of universities, and Java is also used largely in the enterprise, so it's not going anywhere anytime soon. That said, there are alternative languages for the Java platform. In other words, languages that run on the Java virtual machine that can interface with Java that are starting to become more and more popular. These are languages like Kotlin, Scala, and Clojure, and there's others as well. And they can actually work with existing Java code bases because they run on the Java virtual machine, and they're starting to take some of the mind share, some of the market share away from Java. So Java has had pressure on it to evolve, and it started to evolve faster. There was kind of a period about 5 to 10 years ago when Java development had kind of slowed down, and it seemed like Java was a little bit stagnant and not really moving forward as quickly as it needed to stay competitive with other modern languages. But then, in the last 4 to 5 years, Java development has sped up again, and there's been many new versions of Java. They've actually adopted a release cycle where new versions of Java are coming out every 6 months, I believe. It might be 12 months, but don't quote me on it. But Java versions are now coming out quite regularly that are adopting some of the features from other modern languages. So Java is starting to look more and more similar to modern languages like Kotlin or C# or Swift. It's actually getting features that are making it analogous while keeping backwards compatibility. That's one thing. When you have a language that's been around and so popular, it needs to maintain backwards compatibility so that older programs will continue to be able to compile and run on newer versions of Java. So Java has a great backwards compatibility story. You can actually take Java programs that were written in the 1990s and still compile them today on modern versions of Java. And that's not always true about a lot of other programming languages. But when you're an enterprise language where so much critical software runs on you, you really need that. So you see that very much in the heritage of Java.
So Java's really popular, but where is it not used and why?
Because Java runs on this level of abstraction, this Java virtual machine, it is not close to the metal. It is not running directly on the microprocessor. There's always going to be some performance hit as a result of that. And so Java is not a language that's used for low-level development. That continues to be C and C++, which we've done prior episodes on, that's used for things like building operating systems or device drivers. So Java is really an application-level programming language. It is not a low-level programming language, and it probably will never really be used in those areas. There have been attempts, of course, but it's never been a mainstream language for anything like that. So Java has a strong foothold in the areas that it's already prevalent in. Is it going to keep expanding into other areas? I think there's a lot of new languages that are kind of taking mindshare away from Java, like we talked about, some on the Java virtual machine and some that are even not on the Java virtual machine. But it's definitely not going anywhere. It has such a strong connection to the enterprise, to Android, that Java will be around with us for a very long time. All right, thanks for listening to us this week. Rebecca, how can people get in touch with us on Twitter?
We're at Kopec Explains, KOPECEXPLAINS.
And we'll see you next week.
Thanks for listening.